Hi, everybody. So today we're going to be talking about 9.3, which is surface area of cylinders. So before we begin, make sure you have your math composition notebook out and that you are writing down everything that I write down so that you have all these formulas and examples in your notes. So our learning target for today is going to be, I will be able to find the surface area of cylinders. So let's get started. Okay, so if you could please write down what I highlight. So surface area of a cylinder. Let's remind ourselves what a cylinder looks like. So this is what a cylinder looks like. As you can see, when we break it into a net, a cylinder is essentially like a can of corn, you might see, or similar to my water bottle, like this, okay? So the base is a circle, and then the lateral surface is just a big, long rectangle. So notice that a cylinder has two bases, okay? The circle on top and the circle on bottom. We just learned about circles in chapter 8. So our equation is going to have something to do with that. So I want you to write down S equals 2 pi r plus 2 pi r h, okay? And this is how we are going to think about this, okay? I do want you to write down this net as well so that you know that. But when we are finding the area of the bases, okay, so when we're finding the area of the bases, notice it's 2 pi r squared, okay? Well, we remember back to area of circles, that the area of a circle is A equals pi r squared. Remember, apple pies are 2. So it makes sense that we're still using pi r squared, but we multiply it by 2 because there's two bases right here. 1, 2. There's 2 of them. So 2 pi r squared. So we kind of already know that, okay? We're just piecing it all together. And now the area of the lateral surface. The area of the lateral surface is going to be 2 pi times radius times height, okay? So this is a new one. So this is how we find the area of the lateral surface. Remember, radius is from the center of that circle to any point on the outer edge. So the lateral surface can be found by 2 pi r times the height, okay, the height. So you just need to have this equation written down because as long as you know what the radius is and you know what the height is, you can easily plug it in and solve for it. So let's take a peek at an example. Finding the surface area of a cylinder. Find the surface area of the cylinder, round your answer to the nearest tenth. So what I am going to do first is I'm going to draw a net of this. So to draw a net, I have a circle, and I have a long rectangle like that. They should be connecting. Then I have another circle. Okay? So notice the height of the rectangle is 3, and the radius is given to me as 4. So now I'm going to use this information to just plug and chug in my equation. So I'm going to look back to my notes, and I'm going to get that equation for surface area of a cylinder. And it is S equals 2 pi r squared plus 2 pi rh. So now I'm just going to plug in what I know. I know the radius is 4, and I know the height is 3. I also know that pi is equal to 3.14. So now I'm just going to plug it all in. Don't forget your parentheses, though. So I'm going to plug in 2, and then I'm going to leave pi as it is for now, okay? And then r squared, so 4 squared, plus 2, leave pi for now, and then r, which is 4, times the height, which is 3. Okay, now let's just expand it out. So 2 pi 4 squared is going to give me 16, okay? Plus 2 pi, 4 times 3 is going to give me 12. So now this is kind of something that is new in this section. We want to multiply these together because we want to leave it in terms of pi first. So we want to leave it in terms of pi until the very end so that our rounding is correct. So multiply 2 times 16. So that's going to give me 32 pi plus 2 times 12, which is going to give me 24 pi. Now just think of pi as a variable, okay? So those are like terms. So you can literally just add them together. So 32 plus 24 is going to give me 56 pi. Now, once you've combined all those things, then you plug in 3.14 for pi. So 56 times 3.14, and that's going to give me 175.8 millimeters squared. Round your answer to the nearest tenth, okay? That is important. Round your answer to the nearest tenth. So I got 175.84 since that next place over from the tens place is a 4, I round down. So I just keep it at 8. Okay, so that is example 1. Most important thing that you have this formula. As long as you have this formula and you know what the radius is, you know what the height is, you're just plugging in numbers, okay? So make sure you have that down. Now let's look at finding the surface area. So how much paper is used for the label on a can of peas? So note, the label is only on the lateral surface, okay? So that means you're not including the areas of the bases. So you just want to find the lateral surface area, okay, which is all the way around like that. So say we drew the net. All you want to find is this shaded area, okay? You don't want to find the top and the bottom because it's asking you how much paper is used for the label. So that is going to just be S equals 2 pi RH because I know from my equations that I wrote down a couple slides ago, the area of the lateral surfaces are 2 pi RH. So my radius is 1, R equals 1. My height is 2. Okay, so let's just fill it in. 2 pi, radius is 1, height is 2. Let's multiply them out. So 2 pi, remember, leave pi alone for now. 1 times 2 is 2. Then remember, multiply these guys together. So 2 times 2 is going to be 4 pi. And then from there, we substitute 3.14 for pi. And we get 4 times 3.14. We get 12.56. And it does not tell me to round, so I'm just going to leave it as that, inches squared. So that is my surface area for the label on the can of peas. Okay, so that is all for 9.3. Make sure you have all these notes down in your math composition notebook, and we will get started with our big ideas assignment soon. Thank you for watching.